So my dear students, in the previous video we have discussed about this graph. So according to this graph, for the strong electrolyte, molar conductivity slowly increases with decrease in concentration of the solution. But for a weak electrolyte, molar conductivity sharply increases with decrease in concentration. For a strong electrolyte, we have intercept. We have the intercept. यहाँ से यहाँ तक जो value है, that is the intercept. So value of intercept equal to lambda m naught. What is lambda m naught? Lambda m naught is limiting molar conductivity. So value of intercept is equal to the limiting molar conductivity for the strong electrolyte. So limiting molar conductivity for the strong electrolyte, we can find out this. We can find out from this graph. But in case of weak electrolyte, graph never intercept to y-axis. That means from this graph for weak electrolyte, we cannot determine the limiting molar conductivity from this graph. So ये ग्राफ से weak electrolyte के लिए limiting molar conductivity find out नहीं कर सकता है. What is limiting molar conductivity? We have discussed in the previous video. Limiting molar conductivity, it is the conductivity of a solution, molar conductivity of a solution when concentration of the solution tends to 0. When concentration of the solution tends to 0, then solution is called at infinite dilution. Infinite dilution में एक solution का, एक electrolytic solution का concentration कितना होता है? 0 होता है. जब एक electrolytic solution का concentration 0 होगा, then इलेक्ट्रोलाइट का मोलर कंडक्टिविटी मैक्सिमम होता है. दैट मैक्सिमम मोलर कंडक्टिविटी इज कॉल्ड लिमिटिंग मोलर कंडक्टिविटी एंड डिनोटेड बाय द सिंबल ऑफ लैम्डा एम नॉट. किसी बुक में लैम्डा एम इन्फिनिटी भी लिखा, लेकिन अकॉर्डिंग टू टेक्स्ट बुक में लिमिटिंग मोलर कंडक्टिविटी को लिखा लैम्डा एम नॉट सिंबल से. सो फॉर द वीक इलेक्ट्रोलाइट फ्रॉम दिस ग्राफ वी कैनॉट कैलकुलेट द लैम्डा एम नॉट. So how can we calculate the lambda m naught for weak electrolyte? So to calculate the lambda m naught for weak electrolyte, we have to apply another law, which is known as kohlrauch law of independent migration of ion. So in this video, I am going to discuss about the kohlrauch law of independent migration of ions. So what is the application of this law? With the help of this law, we can find out limiting molar conductivity for an electrolyte. With the help of this law, we can find out molar conductivity of an electrolyte when concentration of the solution tends to 0. So, what is the application of the Kohlrauch law? With the help of this law, we can find out limiting molar conductivity for an electrolyte. By knowing the limiting molar conductivity for an electrolyte, we can find out dissociation constant Ka for an electrolyte. So the law is related to the solution at infinite dilution. जब एक solution infinite dilution में होता है, जब एक solution का concentration almost 0 होता है, एक solution को diluted करके solvent add करके solution का concentration almost 0 बना देने से that solution is called at infinite dilution. और एट इन्फाइनाइट डाइल्यूशन ओपोजिटली चार्ज आयन का बीच में जो इंटर आयोनिक फोर्सेस ऑफ अट्रैक्शन ऑलमोस्ट कितना होता है? 0 होता है. सो एट द इन्फाइनाइट डाइल्यूशन cation and anions are independently migrate or move. So at infinite dilution cation का migration anion interfere नहीं करता है, as well as anion का migration cation interfere नहीं करता है. So at the infinite dilution through an electrolyte, cation and anion individually electricity carry करता है. So एक solution जब electrolytic solution जब infinite dilution में होता है, cation का जितना molar conductivity होगा, that is called limiting molar conductivity for the cation, और anion का जितना molar conductivity होगा, that is called limiting molar conductivity for the anion. So through in solution, limiting molar conductivity for the cation, limiting molar conductivity for the anion, cation anion दोनों का limiting molar conductivity प्लस कर देने से एक इलेक्ट्रोलाइटिक सॉल्यूशन का क्या मिल जाता है? टोटल लिमिटिंग मोलर कंडक्टिविटी मिल जाता है. So what is the statement of Kohlrauch's law of independent migration of ion? The law states that at infinite dilution, जब solution का concentration 0 होगा, at infinite dilution, limiting molar conductivity of an electrolyte, limiting molar conductivity lambda m naught of an electrolyte is equal to the sum of the limiting molar conductivities for the cations and anions. So this is the statement of Kohlrauch's law of independent migration of ion. Law states that at infinite dilution, जब solution का concentration almost 0 है, at infinite dilution, limiting molar conductivity of an electrolyte is equal to the sum of the limiting molar conductivities for the cations and anions. So to explain about the Kohlrauch's law mathematically, let us consider an electrolytic solution. Let us consider in this electrolytic solution n plus number of moles of cations are present in the solution, n plus number of moles of cation in an electrolytic solution, and n minus number of moles of anions in this solution. तो हम लोग एक सोल्यूशन इलेक्ट्रोलाइटिक सोल्यूशन कंसिडर किया. सो ये इलेक्ट्रोलाइटिक सोल्यूशन में केटायन, हाउ मेनी मोल्स ऑफ केटायन, n प्लस, प्लस इज द n प्लस, इट इज द सिंबल, इट इज द नंबर ऑफ मोल्स ऑफ केटायन in an electrolytic solution, n minus number of anion in an electrolytic solution. Let us consider one cation के लिए let us consider limiting molar conductivity lambda naught plus. Similarly one anion, एक anion के लिए let us consider limiting molar conductivity lambda naught minus. Let us consider here solution at infinite dilution. At the infinite dilution, how many number of moles of cation in the solution, n plus, how many number of moles of anion in the solution, n minus. Let us consider for one cation how many molar conductivity, limiting molar conductivity lambda plus naught, this is the small lambda, and limiting molar conductivity for one anion only lambda naught minus. So in this solution limiting molar conductivity for n plus number of cation, n plus moles of cation के लिए limiting molar conductivity कितना होगा. So one cation के लिए limiting molar conductivity how many, lambda naught plus. So n plus moles of cation के लिए कितना होगा, n plus into lambda plus naught. This is the limiting molar conductivity for the n plus moles of cation in this solution. Similarly n minus number of moles of anion के लिए limiting molar conductivity कितना होगा, n minus into lambda naught minus. So this is the limiting molar conductivity for the n plus moles of cation in this solution, and this is the limiting molar conductivity for the n minus number of moles of anion in this solution. So दोनों का limiting molar conductivity को प्लस कर देने से, ऐड करने से, then we have limiting molar conductivity for this solution. So this is the mathematical form of the Kohlrauch's law of independent migration of ion. So let us consider an example. Let us calculate the limiting molar conductivity for the potassium chloride solution. So potassium chloride when ionizes produces 1 mole of potassium ion and 1 mole of chloride ion. That means n minus equal to how many, 1, and n plus equal to how many, 1. So applying the Kohlrauch's law, lambda m naught for potassium chloride solution, n plus how many, n plus equal to how many, n plus equal to 1 mole for potassium chloride. Then in place of n plus we can put 1 into lambda naught limiting molar conductivity for the potassium ion plus 1 into, क्योंकि number of moles of anion also 1, then number 1 into limiting molar conductivity for the anion. Similarly, suppose you have to calculate lambda m naught for calcium chloride. So lambda limiting molar conductivity for potassium chloride solution find out करने के लिए examiner limiting molar conductivity for the potassium ion and limiting molar conductivity for the chloride ion are supplied by the examiner. Similarly, suppose हम लोग कैलकुलेट करना है लिमिटिंग मोलर कंडक्टिविटी फॉर द कैल्शियम क्लोराइड. सो कैल्शियम क्लोराइड आयोनाइजेस टू produce 1 moles of calcium ion and 2 moles of chloride ion. So 1 into lambda naught for calcium ion plus 2 into lambda naught for chloride ion, like this. So lambda naught for calcium chloride फाइंड आउट करने के लिए भी हम लोग क्या लॉ अप्लाई करना पड़ेगा, कोलरास लॉ अप्लाई करना पड़ेगा. सो अकॉर्डिंग टू दिस रिलेशन लैम्डा एम नॉट कैलकुलेट करने के लिए फॉर कैल्शियम क्लोराइड, कैल्शियम आयन का लिमिटिंग मोलर कंडक्टिविटी, क्लोराइड आयन का लिमिटिंग मोलर कंडक्टिविटी मस्ट बी सप्लाइड बाय द एग्जामिनर. सो let us consider equation. Let us calculate limiting molar conductivity suppose for potassium sulfate. Potassium sulfate का limiting molar conductivity find out करना है. So limiting molar conductivity for potassium sulfate find out करने के लिए molar conductivity, limiting molar conductivity for potassium ion is given 73.5 Simon centimeter square per mole. Simon centimeter square per mole, it is the unit of molar conductivity. Similarly, lambda naught limiting molar conductivity for sulfate ion also given in the question. Sulfate ion limiting molar conductivity for the sulfate ion 160 Simon centimeter square per mole. So now we have to find out lambda m naught for potassium sulfate. So when potassium sulfate ionizes, produces 2 moles of potassium ion, 2 into limiting molar conductivity for the potassium ion, and produces 1 moles of sulfate ion, 1 into limiting molar conductivity for the sulfate ion. So 2 into limiting molar conductivity for the potassium ion given in the equation, how many? 73.5 plus limiting molar conductivity for the sulfate ion given in the equation 160. So after the calculation you have the limiting molar conductivity for potassium sulfate in which unit? Simon centimeter square per mole. Simon centimeter square per mole is the unit of molar conductivity. So what are the application of Kohlrauch law? So with the help of Kohlrauch law we can find out limiting molar conductivity of an electrolyte. Second application, with the help of Kohlrauch law we can find out degree of dissociation, which is denoted by symbol alpha of a weak electrolyte. How can you find out? What is the relation? Degree of dissociation of a weak electrolyte alpha equal to lambda mc divided by lambda n log. So this is the relation to find out degree of dissociation of an weak electrolyte. So weak electrolyte का degree of dissociation alpha find out करने के लिए हम लोग first of all lambda mc molar conductivity of an electrolyte at any concentration C हम लोग find out करना पड़ेगा, and lambda m naught limiting molar conductivity for the electrolyte must be supplied by the examiner. What is the relation to find out lambda mc? Lambda mc find out करने के लिए relation है lambda mc is equal to kappa divided by c into 1000. So this is the relation to find out lambda mc. Lambda mc means molar conductivity of an electrolyte at any concentration C. So lambda mc find out करने के लिए conductivity of the solution and concentration of the solution must be supplied. So this is the mathematical relation to find out degree of dissociation of an electrolyte. Third application to determine the third application of the Kohlrauch law. With the help of Kohlrauch law we can find out dissociation constant. This is denoted by Ka of an electrolyte. So dissociation constant of an electrolyte Ka you can find out with the help of this relation C alpha square divided by 1 minus alpha. So this is the relation to find out degree of dissociation of an electrolyte. So Ka, it is called degree of dissociation, C is the concentration of the solution, alpha is the degree of dissociation. So Ka, dissociation constant Ka for an electrolyte find out करने के लिए electrolyte के लिए first of all क्या find out करना पड़ेगा, degree of dissociation alpha find out करना पड़ेगा. Ka find out dissociation constant Ka find out करने के लिए electrolyte का first of all क्या find out करना पड़ेगा, degree of dissociation alpha find out करना पड़ेगा. So with the help of Kohlrauch's law we can determine the limiting molar conductivity of an electrolyte. We can find out the molar conductivity of an electrolyte at the infinite dilution. We can find out the degree of dissociation of an electrolyte. We can find out the dissociation constant of an electrolyte. So in exercise, one example is given, one numerical is given, the numerical number 3.11. In this numerical we have to calculate the dissociation constant Ka of an electrolyte. To calculate the Ka concentration of the solution given, and other quantities are also given in the question. So hope you will discuss this numerical from your textbook. Okay, thank you.